Okay, we're going to solve this system of linear equations by graphing. Now, just so you understand what we're doing, each one of these equations has an infinite number of solutions because this is a line and every point on the line is going to be a solution. So let's find this first. I'm going to use the intercept method. X, I'll cross this out. X is negative 5. 1, 2, 3, 4, 5 here. And y is negative 5 there. And I'll draw my line here. So what this means, what this line is every ordered pair on here is an infinite, is a solution. So we have a solution here, 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 here. There's an infinite number of them. There's an infinite number of solutions here as well. So I'm going to solve this using the slope-intercept form. I'll move my 2x over, and I'll get y is equal to a positive 2x plus 1. So this is the y-intercept, and the slope is like 2 over 1. So 1, and I'll rise 2 and run 1. And this is a solution. Okay, so I'm going to draw this line here. Oops, let's draw it in red, not that that matters. Okay. So there are an infinite, every ordered pair is a solution. There's an infinite number of solutions here, infinite number of solutions here, but they share one in common. That's the solution right here to both of these. And as an ordered pair, x is negative 1, 2, and y is negative 1, 2, 3. So the solution is negative 2, negative 3. In other words, when x is negative 2, y is negative 3 for both lines. That's that point there. Okay, so we're going to graph both of these lines. Since 1 and 4 both go into 4, I'm going to use the intercept method. If I cross out this, x is equal to negative 4, and I put my dot right there. And then if I cross out this, negative 4y is equal to negative 4, so y is equal to positive 1. So there's my line. And I'll graph that. Oops, I missed a little bit. But there's my line there. Put arrows on either side of it. Now for this line, 3 doesn't go into 1, so I'm going to use slope-intercept form. I'll move this over, and I'll get y is equal to negative 3x plus 1. This is my y-intercept, so I put a dot right there. And I have a negative 3 over 1. So I go down 3 and I run 1. And we'll draw that line. So again, what this is, there's an infinite number of solutions for this line. There's an infinite number of solutions for this line, but they share just one in common. That point is 0, 1. So that's the solution for both of them. Okay, because 2 and 3 both go into 6, I'm going to use the intercept method. If I cross this out, 2x is negative 6, so x is negative 3, and I put a dot there. If I cross this out, 3y is negative 6, so y is negative 2, and I put a dot there. And then I'm going to graph this. Let's see. And I'll put an arrow on either side. So that's all the solutions for this line. Now on this line, because 1 and 3 both go into 3, I'm going to use the intercept method. If I cross this out, x is negative 3, and I put a dot right there. Put that in another color so you can see what I'm doing. And then if I cross this out, negative 3y is negative 3. That tells me that y is positive 1. So I put a dot right there. And now I'm ready to graph those. And I put an arrow on either side. So there are an infinite number of solutions here, an infinite number of solutions here, but they carry just one in common, and that's the point negative 3, 0. So the solution to both of them, oops, what did I just do, is negative 3, 0. And I write it with parentheses because I'm writing in ordered pair. What I'm saying is x is negative 3 and y is 0. Okay, here I'm given a system. I'm being asked if this is a solution. All you have to do is plug it in and make sure it works for both. So if I plug it in here, I get x is 5, y is 1. So I have 5 plus 1 equals 6. That's true, it works. And then I'll plug these x and y's in here. 5 minus 1 equals 4. And that's also true. So that works. So yes, this is a solution. So here I'm going to test if this is a solution by plugging these values in. So I have 2 times x minus y, which is 2. Is this equal to 8? Yes, it is. So that works there. Let's try the next one. 3 times x plus 2 times y, is this equal to 20? That's not true. So this is a solution to this line, but not to this line, so it's not a solution to both of them. So we say no. Okay, to figure out if this is a solution to this, I'm going to plug it in. So I have 4 times x, and x is negative 1, plus 3 times y, and y is positive 1. Is this equal to negative 1? Well, 4 times negative 1 is negative 4, plus 3 is equal to negative 1. That's true. So it's a solution here. Now let's try this one. Negative 2 times x, which is negative 1, plus 5 times y, which is a positive 1, is this equal to 3? This becomes a positive 2 plus 5 equals 3. It doesn't work. So this is no, it's not a solution. Okay, here we want to solve by substitution. So what I'm going to do is I'm going to take, I'll solve one of the equations for one variable that's already done here. I'm going to plug that in here. So I'll have 4x plus y, but we know y is 2x, is equal to 6. So 6x is equal to 6, so x must be equal to 1. Now that I know x, I can plug that into either this or this. I'll get the same answer, but the one that's already solved is usually the easier one. So I have y is equal to 2x, but x is 1. So the solution to this is we'll write it as an ordered pair. The x first, and then the y. And that's it. Okay, again, we're going to solve by substitution. This is the equation that's already solved, so I'm going to take this and plug it in right there. So I have negative x minus 4y, and y is 2x minus 1 is equal to negative 14. So now I'll distribute this, and I'll have negative x. I'll have minus 8x plus 4 when I distribute, is equal to negative 14. Negative 1x minus 8x is negative 9x. I'll subtract 4 from each side, and I'll get negative 9x is equal to negative 18. And then I'm going to divide by negative 9. And I'm going to get x is equal to negative 18 divided by 9. Negative 9 is a positive 2. Now, I can plug this in to either one of these, but the one that's already solved is always the easier one. So I'll plug it in there to find y. This is 2x minus 1, and x is 2. So this is 4 minus 1 for 3. So now I have an x value and I have a y value, so I have my ordered pair that I'm after, which is 2, 3. Remember, put the x first and then the y. Be careful not to get it backward. Okay, here again I'm solving by substitution, but neither one of these are solved for either variable. But when I look at these, this is the variable that's easiest to solve for. So I'm going to solve this for this variable by moving my negative 3x over, and I'll get y is equal to a positive 3x plus 0, or just a positive 3x. Then I'm going to plug it into that equation. So I have 3x minus 4y, and y is 3x, equals negative 22. So I have 3x minus 12x is equal to negative 22. And let's see, 3 minus 12 is negative 9. And so here I'll divide by negative 9. And we're going to get x is equal to a positive 22 over 9. So now I've solved for the x. I can plug this back into here, but this is the easiest place to put it back where it's solved. So I'll have y is equal to 3 times x, and x is 22 over 9. This is like a 3 over 1. So when I cancel, 3 goes into 3 once and into 9 3 times. And I get y is equal to 1 times 22 is 22, 1 times 3 is 3. So my ordered pair, I put the x first and then the y. And that's it. Okay, I'm going to solve by substitution. So I want to solve one of these for a variable. X is the easiest one to solve for. So if negative x is equal to this, positive x is equal to a negative 3 plus a 2y. So now I'm going to plug that in here. I have 5 times x, and x is negative 3 plus 2y, minus 4y equals 9. So I'll distribute this and I'll get negative 15 plus 10y minus 4y is equal to 9. 10 minus 4 is positive 6. Now I'm going to move this over by adding it. And I'll get 6y is equal to 24. And I'll divide by 6. And I'll get y is equal to 4. Then I'm going to plug that back into the easiest spot where x is already solved. So x is going to be equal to negative 3 plus 2y. And y is 4. So this is negative 3 plus 8, which is positive 5. So here we have our x value, and there we have our y value. So our solution is your x first, and then your y. And that's it. Okay, for number 29, they're both solved for x. So I'm going to use substitution by plugging this in here, where you plug in that in there, but it's the same thing. So I'm going to have 3 halves y is equal to 3y plus 5. Now if you're like me, I don't like fractions, so I'm going to multiply this, this, and this by 2 to get rid of the fractions. So I multiply this by 2 and I get 3y. I multiply this by 2 and I get 6y. And I multiply that by 2 and I get 10. Now I'm going to move this over by subtracting 6y from each side. And 3 minus 6 is negative 3y is equal to 10. And finally I'll divide by negative 3. And I'll bring this up here. And I'll have y is equal to a negative 10 over 3. Then I'm going to take that and I'm going to plug it into either one. It doesn't matter which one. I think this is easier because it's just one operation. So I'll have x is equal to 3 halves y. And I'll plug in what y is. That's negative 10 thirds. I'll cancel before I multiply. And I'm going to get a negative times a positive is a negative. 1 times 10 is 10. 2 times 1 is... I guess I could have canceled some more, huh? Why don't we do that? I'll cancel a little more, and I'll say 2 goes into 10 5 times. So I'm just going to get a negative 5 here. So my ordered pair is x is negative 5, and y is a negative 10 thirds. And that's it.